only I need the mouse because sometimes I have to go into, okay, I have to go into a one platform, but I can also just later show to the people. Now it's working?
Okay. So can you try to change? Doesn't it work?
Still not really. Oh yeah, now.
No, not very. Can I?
Sure. Still not.
What's wrong?
Or maybe driver stopped working.
I have a spade. I can bring you a spade. This is my high tech. Why is that now?
Oh, no worries. That one? The curvy one or the normal?
That's not bamboo, but.
Oh yeah, now working.
Is this because of? What is that?
No, I think that the slides are not that.
Probably it's the batteries.
Ah, no worries. If I can switch.
Maybe turn them a bit. Sometimes it's enough just to remove a bit of the oxidization. Yeah, the magic recharger. No, it's not the case. What's wrong?
Oh yeah, it seems that you have to really point it. Where is the IR? Okay, then I will try to point. Yeah, this one. If you're close enough, I think it works. Yeah.
Not really. I think it's a connection problem of the USB stick.
Okay, if it works now.
Seems so. Could also be.
Yeah, in worst case, I would just go.
Okay.
Okay. I don't know, you have a magic finger because mine doesn't work. Okay, guys. Yeah. Shall I start?
Yeah.
Good. Yeah. Hope that you're not that much tired because it's the end of the day and I try to not go too much into the detail. My name is Mehdipour from Spectre AG. A quick background to myself. I have a background in the AI and remote sensing. In the past, I was working at University of Twente, and then in 2017, I started to gradually thinking about the ideas that I'd had. And then in 2018, we established a company in Netherlands, in Bentelo. Well, the idea started with simply searching for someone doing something with a drone. And then, yeah, Spectre AG born in Bentelo, which is very close to Enschede, the place that Rolf was saying. Yeah, today I don't go to that many products that might be irrelevant, but in general is about everything that might be there. Yeah.
Okay, let me play for you.
Yeah, indeed, I think it's easy if you...
Just tell me.
Sure. Yeah, the mission the company has is that to make sure that we develop and design the automated AI that our, let's say, clients and users can detect and counting their object of interest, which could be anything. And when I say automated, it means that the workflow from the moments that you train a model, park it, run it, and getting the results and report generation is automated. Yeah, next one, please. Yeah, and the vision is that make sure that it's in the readiness of the user without any background in AI, any background in remote sensing still can benefit it. It's not only the clients in industry, but also in academia because like the other colleagues that was saying that they're interested to collecting a spectral signature, for example, then we also did something like that. Yeah, next one, please. The products list that, as I mentioned, is that at this moment they are listed here. We have a product called BrainBox, and it is a hardware part that all the AI part configured. And if the client has interest in one of the existing deep learning models in parking the BrainBox, they can use it. But if they have their own model, which in these days in university is quite common to train, and some models come out of that, they can park it in there and quickly run it. And we have it for the drone, which is very focused in DJI drones, to detect and count the object of interest from the drone. It could be anything, and also from a generic camera. Yeah, the D4SAT, the D4SAT is automating the AI deep learning for satellite image and drone mosaic. It's called D4SAT, but don't need to be confused. It's satellite. Any GOT file that you have, you can bring it and train a model and deploy it. Hyperslit is the system that actually the target focus spectroscopy system from the drone. It means that you actually flying with the drones and you see where you are doing the spectroscopy measurements with the georeference information. And AI API is a service that we're normally providing when the user has a model but wants it to just, or ask for model but wants to communicate in a command line level and get the result. And the 3D NDVI is the technique that I'm sure that everyone is familiar with the NDVI index and multispectral cameras, but there are several cases that you want to do 3D, like LiDAR points, but now it's like points have also the X, Y, Z, and also NDVI. Yeah. Okay, application area quite broad because we always say that we are helping to detect and count and analyze the object of interest. It could be anything, in environment inspection, it could be in animal and plant conservation, infrastructure surveillance, and the other area. Yeah, next please. Sure, this is the brain box. And it is the GPU-based actually device that the users can connect to that via the wireless. And if you're talking about the drone, DJI drone, if you have already, for example, like Saskia said, I have a DJI drone with a smart controller, you connect to that, and then you quickly can download the app for the drone, and then using the drone camera as a sensor, and start to doing the AI, which I will show you later. And it has its own battery, actually 1 hour, you can do the prediction and data collection with the deep learning in the field if you need it. It has also the HTML-based interface. If you have your own camera system that providing the output, you can connect it to the box and having access to a same web application because you connect to box with the Wi-Fi and then you see the web application, you can do the same detection and counting. And also, there are some pre-parked models like detecting people, animals, different things. But if you have your own model based on the data that you collected or shared with us to train the data and also train a model for you, then you can park it by going to interface, just plus button and adding to that. This configuration of workflow, what I call it the automation of the AI. And also camera input can be, as I said, can be HDMI, USB cables as well. Yeah, next one. Sure, as I explained, that for the drone actually is coming with the application for the smart controller because DJI drones coming with a smart controller. And this controller is an Android device. And then we develop an application called Deep for Drone app. And then you turn on your brain box, you connect your controller to that. And if you're going to next slide, yeah, you see the list of the supported one. Actually, the supported DJI drone, anyone that has the smart controller can be supported. And some drones has also both the RGB and also thermal cameras. And thermal cameras is also possible to be used. It means that you can do the deep learning object detection in thermal as well. And some of them are very high zoom. For example, this Z30 is coming from the DJI and can optically 30 times more zoom. And when we are talking about the detecting biodiversity, which is growing, or some specific type of object which is very small, from, let's say, flying, you can quite zoom and detect it while you're moving. Or in safety and security domain, or fire, for example, if you are with the drone from kilometers, you can zoom and having the, let's say, field of view that is zoomed enough for the object detection using deep learning. And a small drone that coming with a DJI, like a Mavic series. Yeah, I brought also Mavic Air, which is a small €1,000 up to, I don't know, €10,000 these days in market. And this one also supported. I can actually demonstrate it if needed for tomorrow. Yeah, next please. Yeah, as I said, this is the general things that people in Deep for Drone, they see. They see the list of models that already parked. If I want to detect chairs or face, people, dog detection, fire detection, anything. I want to show that it's generic enough. And you have a list of models. You have in the setting tabs, you can actually play with the confidence of the models if you wanted to detect it in different confidence. And also you have a video that you can record and count the total. And also in frame, you have two modes. You can detect the object of interest in the frame, like the other one that Saskia was showing, how many cows are standing in the frame, or just scan an area, see how many in total is there. And also you get a report generation in the last tab. Yeah, next one. Yeah, this is an example, for example, what you see in the Deep for Drone app. Here was it just generic that you see that, okay, how many cars is standing there is in the frame mode. But you can also switch it and also having a total calculation in mode. Yeah, next please. Yeah, some use cases during the day. If you're talking about the clients, these are some samples that client wants to scan a parking lot and see how many objects in total are standing there. Or here in our company, here from 1 kilometer away, we zoom with the Z30 to detect object of interest is a people standing there, and also 6 people are standing there in safety and security domain. Or in weeds, actually, because I had the Germany project in Lower Saxony, I collected a lot of images with the bitter dogs, and now we have a good bitter dogs model to detect and count how many when you are moving. Or the animal detection, or if in waste domain we are saying, for example, plastic bottles or the biodiversity. For example, this is an example that when you can actually very high zoom and detecting something is growing in the ground. Yeah. Okay, this is a RGB based, but this DJI camera has a thermal also integrated, like a Mavic 2 Enterprise, for example. It's a cheap, like €5,000 drone, and you can switch it between RGB and the thermal. If you have a video or collected images with the thermal, you can train, and here what you see is a thermal, really, object detection. During the night, we did a recording from the horses, for example, as a just use case with the safety and security domain when actually we're flying. Yeah, technically, just to show you can do different things. The same things that you have an application on a drone, we also have an application for the HTML base. It means that when you have a laptop or computer, you can connect it, or if the Brainbox is part of your network by LAN, you can go to one URL and see the same application and use the same functionality. And as an input of the camera, it could be USB, HDMI, or LAN, let's say. Good. Yeah, this is another thing that actually detecting in the field, for example, in the office, when our developer was just doing the test, and then actually it was a camera that is standing on the one table, detecting and also masking the face of people because of this privacy issue indeed. Yeah. Okay, this was the Deep4 drone, when actually the detection is needed in real time, like first responders, firefighters. Now with the Rolf, we are in a project with the Interreg. We wanted to doing some system that in the hardware level, this is the out-of-the-box drone. They put it one box with the drone there, and this box every couple of hours open, goes up, do some changes, check if the fire or plumb is actually detected, and then if yes, just sending some messages from the box to the fire department, as an example. First response is like a police, I don't know, inspectors in the food and safety, or the construction, sometimes the real-time detection is needed. But there is a platform that actually, for the moment that no rushes exist. Imagine that you have a satellite image or drone mosaic of the area, but you want to do object detection and count them and download the shapefile, which is the map of the object detected. It could be, for example, cars or the weeds on the ground. For that, actually, we have a platform called deep4sat.com. You can actually go in there, make an account, have a free credits also to use in a small images to try. And the user bring it and upload an image, throw a $50, for example, to start. A minimum, we say, never you get a good model with 50, of course, but you have to force the user to start. And then when they finish the labeling by drawing tool, or maybe if they have a shapefile layer of the object, they can upload and use it. Then after that is automated, because they can just click, they don't need to know that much coding, they don't need to know that much things. And then they see first the prediction. I believe that, Rolf, if you click here, actually, on the platform, you go in there, if I'm not mistaken. Otherwise, if there is interest, actually, I can show it how easy. But
okay, it's coming up here in another one.
but I think that it maybe takes a bit time, because I have a lot of projects like tree detection, animal detection, here, for example, there was a municipality was interested in Enschede to detect a red roof houses from the satellite images, this different thing. I can log in. I suggested not to do it now. I do it after because of lack of time.
We have time tomorrow.
Yeah, and then if you're going further in the presentation, I can show you some slides, for example, that is some sample of that. Yeah. This is a long video that shows how the platform helps actually, I think automatically it should run if I'm not mistaken. Oh yeah, it's a start. Yeah, user just drawing first an area that they are interested to give some labels as a sample, and then it started to labeling some couple of, here in this case, car, to introduce it. This is the car I'm looking for, and then after that they see the predictions. I suggest that we're going further with one slide that all of the things there. This slide, yeah, in platform, after seeing the results first on the uploaded image for training, they can see the results, and if they are interested, they can go back or using another image to improve the deep learning model. And they can download the center of the boxes as a CSV. They can download the shape layer of the boxes as a shapefile. And when they pay for the training, actually, they have a model, which they are the owner of the IP of the model, with the agreement that they are staying in our platform, use it in future. And if a new images, after some time coming from the same area, or they wanted to use the model to detect over a new area, they can upload a new image and use the same model, this time faster, cheaper, just get a prediction layer. Yeah. This is another example, yeah, like detecting airplanes. Here in Rotterdam, we actually did a project with the municipality of Rotterdam because they were interested to detecting the zebra crossing icons on the street because no one had that layer. And the guy said that if you generate that layer, is a big layer of information for a whole municipality. But they say we don't have a time, just use the platform and do it. These are all the cases that the user did it themselves. We didn't do anything for them. There was also a project that actually they detected solar panels installed on the buildings. Red roof houses, because municipality wants to control them. There's a specific type of ceiling that they know is on the red roof and just several reasons. There was also a project that we detecting a specific type of pines, which is actually in Netherlands exists. And this is a good example how the Deep4 drone can be used in the fire-related project. If you're talking about a specific type of species, the object from space, or the airplane images, they can use it there. Yeah. Yeah, this is also a good example. We had a client that they fly with the RTK GPS drone, and they train really based on the 50 bitter dogs in this case. Actually, they train the model, and then after that, they see the prediction, which is everywhere these weeds are growing on the grass fields. And then they downloaded the layer of these weeds and give it to tractor because it was shapefile for a standard format, and the tractor can read it. And then they did a spray. After 1 month, again they did a flight, and they again checked the control to see how the weeds and the spraying was effective over the fields, for example. Yeah, yeah. Sure. This was the D4 drone, D4 sat. And now we are saying, I think that this is quite related to the previous one. I'm not going to explain everything about the spectroscopy and everything because everyone is the expert and follow the last presentation. But we have a system called hypersleed. And hypersleed is a flying spectroscopy technique that collecting the measurement, which are the reflectance measurements, by the way, from the downwards. And from upwards, per measurements, also we're getting irradiance and measurements from the sky, 180 degree on top of the drone. Next, please. Yeah, we have different models. Visible, UV, and near infrared, you can see, and the spectral resolution is 0.5 nanometer. It means that every half a nanometer, we can collect the measurements, and the sensor now is quite plug and play for DJI M300. It means that we are not producer of the drone. If the client has his own drone, they can actually just automatically install it and just 4 screws on top, and then they have it. This is irradiance sensors, which is also a spectrometer, 1,000 channels, and also downwards here. This is, for example, all of the sample which is collected. If you're going further, I will show you. I should not forget that it has on RTK GPS, IMU, Wi-Fi, and this is an example of the grass use case because we collecting whatever is inside the slits, and on the left side, actually, you can see the spectral signature at the real time. And here, one machine learning models is actually trained and parked, that whatever is a spectral signature goes inside as an output is coming and showing the quality of the grass, how many grams per kilogram crude protein exists on the canopy, of course, of the grass. And the user can also log it. This is the project in Netherlands with the Mineral Valley 20, actually in Norwegian. Almost 4 years, we're collecting from the sky the measurements from the ground, grab a sample from the grass and send it to lab, which is Eurofence lab, which is Wageningen. And actually, now, as you see, when the drone is flying over the field, each of these green points are one sample that you showed also, one spectral signature. And then also we have a post-processing platform, which is Hyper for Grass, and generating the protein map out of this. And this maps is also the georeference. You can get the shapefile or GeoTIFF downloaded and see it. Unfortunately, there is no time. If you're going to the Hyper for Grass later, I can show you how we combine it with the 2 weeks weather prediction to see how the protein change, how the dry matter changes.
That's something we can discuss tomorrow.
Yeah, this is also could be interesting because if you're talking after the fire, flying over an area and collecting a spectral signature, you can map it at least, generate the layer of the ashes or whatever left it after the fire, and just 1,000 maps at least to have data. Let's say it's a data collection measurement. We are at the end not interested to be in use case part, but we are, as a company, interested to offer it as a measurement tool. Yeah. Yeah, this is the 3D NDVI because by the way, going back to the price, because for the hypersleep, the price is much cheaper than normal hyperspectral cameras. Of course, we're sacrificing the spatial resolution, but we have a more spectral resolution. 3D NDVI generator is a combine of the hardware and software, and there are several cases that LiDAR is expensive, but still photogrammetry technique works. And what we did is we designed hardware and software for the one multispectral camera, which is part of Sequoia. Perhaps some of the colleagues are familiar. We collect the images during flight from 2 different angles, And actually, after the data collected, this is a project in Germany, in Winterberg, and because it was a hilly area, they wanted to see the point cloud, which is X, Y, Z, and also the NDVI values, and then they wanted to filter to find some of the trees that might be from the side seek and not from the top canopy. Because the issue is that when you fly only with it 90-degree looking downwards, you generated 2D maps, and you project a large area of the tree only to 2D, and then you're losing the sides. Or if you're talking about very slopey or very hilly area, then this area when projecting 2D will be a small part only. Yeah, and this 3D NDVI came with one scientist which was in US, and they wanted to fly in Afghanistan and monitor the rangeland change with the bushes and everything in 3D, but because they say if you're looking at satellite images or with the airplane, everything in the very Afghanistan with the very high slope mountain, everything projecting 2D and very small, and then this idea came there. Yeah, this is comparable with the LiDAR, but of course the position is not as accurate as LiDAR. It has a limitation because when it's windy, the results are really not good. And but we did a test also in vineyards and just to check actually from different sides of the rows of the grape trees, and just checking to see actually we can generate a point cloud, which is showing something from the sides. Partner-wise, this slide needs to be updated. We were working with different companies, universities, and in Germany, for example, we did a 2 years project with the Grass Center in Bremen, which project was supported by Minister of Agriculture in Germany, and also with the Minister of Agriculture in Netherlands we did a project. We are officially partner of Esri also, and university-wise Wageningen, University of Twente, Haas, and Rijnwald, I believe that I added today. And we actually working really with we try to stay with the end users, at least in terms of business that are working with the end users. And related to the fire part, we didn't do that much project, except that in the past, because we were part of the association in Dutch side called Space 53, they are very focused on the safety and security by drone, which, as you mentioned, Martin is one of the guys, and they are really good in using drones and sensors for fire monitoring. And the idea by developing a system, that early warning system about the smoke and the flame of the fire, could be very interesting, because if such system exists, then there are several places, not network of the camera not exists, or it's quite time consuming to do the monitoring. But for that, actually, what I see is that university, when they doing a feasibility study with different type of data, different type of sensors, actually, or training a good model that at the end can be could be very place of the collaboration with the companies and universities. Yeah, we are quite open. And of course, we don't see the universities as a competitor at all. I actually see that quite, we are happy that they tested the feasibility, because the knowledge is in the university. And it's very good that the people that have the knowledge test something before the companies wants to spend the money, energy to develop something really in industrial level working. Yeah, this is the view in the company indeed. And now we are almost 12 people after, let's say, almost 3 years and a half. Yeah.
Cool. Thank you.
Yeah. And any question? Of course.
Have you're calling the list of prices?
Yeah, technically some of the prices deep for drone and stuff are on the website. For Hypersleep it's almost 27K, and I personally have it, but I believe that most of them are also on our website, which is spectroag.com. Yeah.
Okay. Do you have a leasing program?
Sorry?
A renting program?
Renting no, of course. I don't think that actually you should at the end rent from us. I believe that with the collaboration, one project can be, because if you have the budget, we can bring the tools, of course, in the project. Yeah. Why you should pay or we should pay, if there is some funding. Yeah? Okay, perfect.
Fantastic. Thank you so much. Okay. Who's doing this? You?
Thank you.
Oh,
sorry.
thank you. Here? Okay. Let me start the presentation first.
And may I use this one?
Yes, but give me a second.
Okay.
Okay. 5. Okay, it seems to work. Okay, please.
Okay. Thank you. My presentation will be more general about our university, some about equipment, and 2 examples of use drones and satellite photos for development plan, and also for revitalization of post-fire areas. I prepared with my colleagues with service drones at our university. Oops.
It's working or not? Then I press for
Oops. Yes. Warsaw University of Life Sciences, former Warsaw Agricultural University from 20 years ago, in English, but in Polish as GGW, it is in Polish Szkoła Główna Gospodarstwa Wiejskiego, is still the same from 1918. But pioneer of this university was Institute of Agronomy in Marymont, also in Warsaw, in former Warsaw, from 1816. University located in the south part of Warsaw, in district Ursynów. It is old town of Warsaw. Okay. Fields and main disciplines of research at Warsaw University of Life Sciences is connected with 3 scopes. One of them is engineering and technology. There is also my institute, civil engineering, and also environmental engineering, information and communication technology, and mechanical engineering. And also in agriculture science, there is forestry. Oops. Okay. And institutes covered research disciplines. In these 16 institutes, one of them is civil engineering, and we cooperate also with mechanical, environmental engineering, which is becomes from Faculty of Environmental and Civil Engineering. But now, after last reform, teaching is separate. The activities of university is located at faculties, but research on institutes is not good, I think, but is decided by authorities. We have 14 faculties, only teaching activities, and in this Faculty of Civil and Environmental Engineering, total university have about 20,000 students. In this 1,800 foreigners and 1,700 academic teachers. Our faculty consists 2 institutes, I told earlier, and my institute, Institute of Civil Engineering, consists of 4 departments. The department connected to this subject of this cost action is Department of Geotechnical Engineering and Department of Revitalization and Architecture, particularly revitalization part. There also, okay, and also in the Institute of Environmental Engineering, there is Department of Remote Sensing and Environmental Assessment. And faculty have 3 stages of 3 degree stages. It is about 2,000 students and 170 teachers, 5 courses on Polish language on first and second stage of university education. Consists of civil engineering, environmental protection, engineering and water management, and landscape architecture. 4 courses also in civil engineering, environmental engineering, and also environmental protection. And double degree agreements with in civil engineering with Ukraine from Rivne, and double degree from Astana University in Kazakhstan. And our campus, our institute and faculty located in the center of this campus. And one of the examples which I will present is Radiowo Landfill. Radiowo Landfill is located in the opposite side of Warsaw, in the northern part. It is a very interesting location because there is small airport. It is sports and also for medicine service. 2 reserve parks, landfill, almost 20 hectares, waste treatment and composting plant. There is large, in the biggest in Poland, fuel storage tanks, where was fire about in 2011. One of the tanks was burned, and petrol station and other facilities, service and also factories, because there is Warsaw steel factory. And very close, it is about 2 kilometers from this landfill, there is Kampinoski National Park. The last fire accidents on the landfill was about 7 years ago. And now we closed this landfill. This is 5 years ago, was completely closed, and we prepare new development plan using also from drones measurements, and there is plan to locate it there, ski slope, like maybe in Botrop, close from here. There is view from drone. These natural reserves, and Kampinoski National Park located from here, and there is. It is more than 60 meters high. The people told that is the highest hill on the Mazovian region, where this very flat region. And we use LiDAR system and other system for create 3-point cloud from LiDAR system of Radiowo Landfill was used for numerical model of the surface for the purpose of monitoring and, for example, displacement and new development plan. And this is from visualization from the project. New, maybe for a few years will be realized, and there is a ski slope about 600 meters long, like in Botrop. Botrop is 650. And I don't know, it will be investor which give money for facilities, for install facilities for skiing. We try find it. And this is view from drones. This it's new from few years. This, and also yeah, yeah. We have different photos I take to the presentation, this one. And also, of course, we have many different tests on this landfill, and not only this landfill, we have another sites where we use non-invasive methods like geophysical test and other chemical and physical analysis of soils, water, leachate, and wastes. And drones and sensors used for take some information about these areas from LiDAR system, from UAV platform, and also, for example, thermal camera. This is road, entrance road on the landfill with the temporary with concrete slabs like this. There is hot, there is cold surface because there is about 2 meters sands under these slabs. And also we use drones and sensors, for example, for photos on flood protection embankments like RGB, spectral camera, and create numerical model for information about safety of this. And the second example is the famous fire accident in Biebrza National Park, which was in April 2020. The total area covered by the fire was more than 5,500 hectares, including more than 4,500 within Biebrza National Park, and almost 1,000 hectares of the buffer zone, the forest enclave. Biebrza National Park is the largest wetland in Europe. It's very good. The fire include 3,300 hectares of state owner land and more than 2,200 of private land plants. Huge loss of avifauna and other groups of animals. Comprehensive fire monitoring was launched in terms of the fire impact of the Biebrza nature, including drones and satellite maps. One day, fire area increased by approximately of 1,500 hectares. It is from 20 to 21 April 2020. But now, after 2 months, this on the wetlands area, this burnt area was completely covered by vegetation. It is very fast. Vegetation become, but more losses with animals because this is and this photo from satellite. This is very small because it is about 80 kilometers and there is 150 kilometers area. It is very small because and next after 2 days it is increased from satellite, and 3 days after start of the fire. And also from one satellite, another satellite area covered close to the city Gonions. 10 kilometers from here, it is my birthplace. I was born very close to this area because it is on Podlasie. It is eastern part of Poland. And recent publication, our publication related to FIRElinks, one of with very high impact factor. and other one also we prepared connecting with fire problems and connecting with renewable area after using for other activities. And a few years ago, we have also a cost action European cooperation in science and technology, impact of climate change on engineered slopes for infrastructure. I am civil engineer, and we, for us, very important protection against erosion, and also construct some protection solution for before landslides and other damage. And also one of with Artemi to tail land degradation and development, and also use vegetation for natural strategy for landfill restoration. It is concerning with our one of our landfill. And thank you for your attention.
Any questions?
I retired.
The
Center of
laser
the-
scanner you are using, what was it again?
Pardon?
The laser scanner you are using with the M300 drone.
I don't know because my colleagues service
it's
this.
good.
This
Yeah.
I told you I showed them on the first slide.
And from which department are the colleagues who are operating?
Remote sensing,
From remote
Faculty
sensing?
Department of Remote Sensing. Hormański and other colleagues.
So in your
We-
your faculty or your institute or department is that of civil engineering,
Civil engineering.
and environmental engineering
Yeah,
as well,
yeah,
right?
yeah.
And what are you covering in environmental engineering?
Particularly for water engineering,
Okay.
and also installation and ground remediation and remedial problems on degraded areas, and not only from waste management, but also in after factories and other industrial activities.
I'm asking because my daughter is studying environmental engineering at the RWTH
Uh-huh.
bachelor's level, and I don't know what she will do afterwards.
You know.
Yeah, I was wondering, like the landfill that you study, I suppose that you're then also looking into, problems that this landfill is causing. From
It is very old landfill. It is start in 1960. There is no no line in afternoon, but we have a vertical barrier surrounding landfill, surrounding this landfill. It is to the deep of 7 to 20 meters to the clay layer.
Oh, okay.
It is surrounding landfill.
It has a lot of bad things in
Yes,
it.
yes. It is bentonite 60 centimeters barrier.
Yeah.
Surrounding this landfill, and also peripheral drainage between landfill and vertical barrier to drainage leachate from the landfill. Okay.
Yeah. Because what does it contain? Specifically, and what it really
It is
does?
it's difficult question.
Yeah,
It is very old. The problem is remediation. There's no construct this landfill, but only protection against influence, against to the protected areas.
In the Netherlands, we have landfills like that. In the past there were no
Okay.
regulations at all. They just put anything.
And now we also close this
But
such
they do
landfill.
exactly, in the Netherlands, they do exactly the same. They just isolate
Okay,
because it's
okay.
too expensive to really.
Yes,
take out.
yes, it's very expensive.
Yeah,
Mhm.
it's not possible. to-
But there's only solution for protection before
Yeah.
pollution,
They don't
transport
seal
in
it-
the
they
groundwater.
don't plan to seal it off on the top.
Yeah. We covered by mineral, by clay layer.
On the
20 meter,
surface,
2 meters.
so it's really like a package now.
It's different. This is, but also it's very important. Is also vegetation, good vegetation. Of course, it's the gassing system was installed and protect this emission to the atmosphere.
Oh yes, these two. Okay, then we have only demos left.
Okay. Thank you.
Thank you.
Thank you.
Oop.
Sicherheitswarnung.
Oh, security. What's that?
You know what? There are 2 videos in there. I'm not going to.
Extend
play them.
the
I'm going to skip them. So
I
those
activate.
videos.
I trust you.
Thank you. So I'm Yanis. I come from Crete, the one without the face here, and I'm in the I'm in the Hellenic Mediterranean University. I work for these people here. Dr. Thosevoulos Manios, Ioannis Taliakopoulos, Dimitris Papadimitriou, which, by the way, is the one who's going to participate in the with Jesus on your program, on the short-term research. Yeah. So not the department, the I should say, well, I'm in the agricultural department. Our team has to do with water management resources, designing optimization for nature-based wastewater treatment, reuse of water in agriculture. We also deal with smart agriculture, crop irrigation strategies, climate change impact studies, design and implementation of irrigation monitoring and other things. We also deal with hydroponics, soilless agriculture. We do we study hydraulic properties of hydroponic substrates, and we also have several products having to do with projects having to do with soil amendments. And we also deal with compost. This is, by the way, that's the that's the high prop that you're going to use. Don't do that. It's not going to do anything. I mean, don't plan a garbage there. That's just us exploring. Yes. We also have bioplastics productions from food waste and other sources, biofuels, and we also have UAVs and 3 licensed pilots. We have a fixed-wing SenseFly. Sorry, okay. We produce DEMs. We have a hydrocopter UAV DJI Matrix, and these are the cameras that we have as attachment for it. And relevant research when it comes to today's topic. We just started. So what I have, oh no, this is the relevant research on the UAVs. Sorry. Yeah, this is for essentially for the island heat effect, and for today's topic is we have taken samples from Kerry Forest, from Heraklion, which is regularly gets fires. These are two videos that I'm going to skip because we don't have much time, so you're not going to see my editing skills.
But we
Come on.
can share one. Why not? Is there anything you would like to share with us? We can.
Yeah, we are not in a hurry. You go ahead.
Don't worry.
Time, you have time to.
You would like to see the video?
Yes.
All right.
So what would you like to present?
This is just a video of us during the React Format project that we visited the Kerry Forest, and this is a video showing some of the damage.
Should I start it?
Yeah. It takes about 2 minutes.
Did you compose the music?
No, no. This is Yannis using the drone, by the way, not me.
Oh, sorry. Sorry.
You know what? It takes a bit of time, so.
No, it's okay.
Is there elements in video?
Sorry.
Not that we're in video.
No. Yes, right.
No, it's really.
Yeah. History probably. All it.
Why this object was interesting?
Sorry.
Why this object, the snails were interesting?
The snails in particular, it wasn't something about it. It's just a nice photo. Okay, that was the video.
Stop.
Yeah, yeah. Can I-
Okay, so I think.
No, nothing. Yep. Okay. So I took some samples, some soil samples from this area. Took 3 samples in the burnt area and 3 samples on the not burnt. And I used the hyprop. This contraption, I'm sure you're going to need that. By the way, it's that's not me.
Sorry. I got a video call on my laptop.
Okay. Anyway, we having this contraption made us shove off about a day from the measurements. So you may want to do that. Sorry. What? There you go. And so far the measurements show that there is just a 3% difference between the unburned and the burned soil on the volumetric water content. There is no difference in the water conductivity. So unfortunately, little interest there. But the measurements are going to we're going to keep taking more and more, and I hope I can evolve it, find new ways to new measurements for the soil and measure the damage, if there is any. And that's it for me. Thank you very much. Yep.
You measure the water retention curve drying or wetting?
No, drying.
Dry. We saturate the sample.
Sorry?
You saturate the sample.
Yes, you saturate the sample for 24 hours, and then you measure it with high prop, how fast it loses the water. Anything else? Nope. Okay. Sorry?
No, nothing. Thinking of the shape of the curves.
But you calculate the rest of the curve with a model, because you only use the height, but you don't use the cassette and the other devices to compute.
No.
Or the
You don't have to have it. You don't have to have it.
yeah, but it's a model, it's not the reality. Right?
But you go down to which potential? The graph back.
Yep. Sorry. Can we have the presentation one?
Sorry.
There you go.
Oh, we don't see.
Yes, I am.
Maybe
My positioning is a problem here. If we can.
Okay.
three, right?
Sorry?
Three.
The
Three.
Yeah, 3. Yeah.
Yeah.
It goes a bit further, but the measurements stop here, so I didn't think I should have the whole.
So to complete the rest of the curve, you need a different instrument.
The rest of the curve to complete it.
In a 2PF file.
Well, there's going to be a point. There's going to be a point that you are not going to get more out of it, and Hyprop is really close to it.
With that instrument, yeah.
Yes.
What I mean is when you build a water retention curve, usually you, the classic soil science stuff, it goes down at least to the permanent building point, which is 4.2 PF, something like that.
Well,
So with this
if we had.
instrument, you cannot reach it. This is what I'm asking.
I didn't reach it. No. You can have the model. You can have the model. But these are the measurements that I had from those two samples, and it wasn't good enough, I think.
Okay, so to those points that are experimental points that you measure, then you fit a model, retention model or something like that.
The model, you get the model from the Hyprop Fit, their software. Okay.
Okay. Would you please give me the microphone, please?
Oh, sorry.
I can help you. Thank you. Okay, I think the official part of today is over, right? So let's meet tomorrow here again at 9 o'clock. And I think we still spend some time now, right, together, and maybe also arrange the transfer tomorrow and think about the cars, and let's have a drink. And so thank you so much for your great presentations and your introductions to your institution, yourself and your work. It's really fantastic. So now tomorrow we can dive a bit deeper in the discussion also on Wednesday, right? Thank you.